Dear children, we are going to start the new chapter, Introduction to Trigonometry. The word trigonometry is derived from three words. Tri means three, gon meaning sides, and metron meaning measure. Therefore, trigonometry is the study of relationship between the sides of the angles of a triangle. Now here we are going to describe the three sides of the triangle with respect to the angles. Now this side, which is opposite to the right angle, is fixed. It is called the hypotenuse. And the other two sides are described with respect to angle A. This side, which is opposite to angle A, we describe it as side opposite to angle A. And this side, we describe it as side adjacent to angle A. Now you have to understand that both these sides are adjacent to angle A, but one we have already named it as hypotenuse. So whenever we say side adjacent to angle A, it will be this angle other than the hypotenuse. Now let us find the trigonometrical ratios, the names which are given to the trigonometrical ratios. Here afterwards we are going to use T ratios for trigonometrical ratios of the angle A. Now sine of angle A, this is the complete form, sine of angle A, abbreviation is sine A. It is now for this angle you can see sine of A is side opposite to angle A divided by hypotenuse. Similarly, the second ratio, that is cosine of angle A, it is defined as the side adjacent to angle A upon hypotenuse. The side adjacent to angle A, this side, upon hypotenuse. The tangent of angle A, also called tan A, it is defined as the side opposite to angle A by side adjacent to angle A. So tan of A is side opposite to angle A by side adjacent to angle A. So these are all the meaning of these ratios which you have to by heart. Now, having done these three ratios, if we take the reciprocal of these three ratios, we are going to get three new ratios. The first one, we see the reciprocal of sine. So it is called cosecant of angle A. In short, it is called cosec A. It is the reciprocal. 1 upon sine A means reciprocal of sine A. It is hypotenuse upon side opposite to angle A. So cosec A is hypotenuse upon side opposite to angle A. So it is AC upon BC. Similarly, the other two reciprocal ratios, secant of angle A, also called sec A, it is the reciprocal of cosine of angle A, and it is defined as hypotenuse upon side adjacent to angle A, that is AC upon AB. Then cotangent of angle A, that is cot A, it is the reciprocal of tan ratio, 1 upon tangent A. So it is side opposite to angle A by side adjacent to angle A upon side opposite to angle A. So these are the 6 ratios. So these are three ratios. Main 3 ratios are sine A, cos A, tan A, and their reciprocals are cosec A, sec A and cot A. They are the reciprocals. Now we can also see two more relations. That is, we can see that sine by cos, if we divide sine by cos, we will get BC by AB, which is nothing but tan A. So you can say tan of A is nothing but sine A by cos A. Similarly, you can show that cos A by sine A, after cancelling these common denominators, you get AB by BC, which is nothing but cot A. So we can say cot A is equal to cos A by sine A. So in all we have, you can see that 6 ratios and these two relations. So we have to understand where we are going to use it. Basically, we are going to mainly use sine and cos. And the remaining ratios, suppose you are getting tan ratio, then we are going to write it as sine by cos. If you are getting cosec A, we are going to write it as reciprocal of sine A. If you are going to get sec A, we are going to write reciprocal of cos A. If you are getting cot A, we are going to write it as cos by sine. Okay. Now let us see some remarks. We have to understand that sin A is an abbreviation, that is short form of the sine of angle A. Sin A does not mean the multiplication, the product of sine and A. This is not the multiplication. This is a single word. Sin A is a single word. Now sine separated from A has no meaning. So if you simply write sine, cos, tan, they have no meaning. Now for the sake of convenience, if you have sine A whole square, we write it as sine square A. Similarly, if you have cos A whole square, we write it as cos square A. But cosec A, which is the 1 upon sine A. You see, if you bring sine A up, it becomes sine A raised to minus 1. You cannot write sine A raised to minus 1 as sine minus 1A. This is not correct. So cos A means sine A whole raised to minus 1, but it cannot be written in this manner. Okay. Now this is a very important point, that if you have small triangles, big right angle triangles which contain the same acute angle. So what happens? That the sides of the triangle may be big or small, but the trigonometrical ratio of the angle associated with an angle, that does not change. Even if the length of the sides may become small, may become big, depending on the size of the triangle. Well, now if out of the 6 ratios, if you know one ratio, we can find the remaining ratios either by algebraic method or by geometrical method. So first we will focus on geometrical method. Now you can see here the first exercise we are starting, the first question. Here we are given two sides, 24 and 7. So by Pythagoras theorem, we find the third side, that is 25. Now once you know all the 3 sides, we can find any ratios. So we have found sin A. Now sin A means you have to always keep like this. Sin A means opposite side by hypotenuse. So that is BC upon AC, that is 7 upon 25. Then cos A, for the same angle cos A. Cos A means adjacent side by hypotenuse, that is 24 by 25. So this is for angle A. Now for angle C, you can see this angle C. For angle C, sin C means the opposite side of C will be this one. Sin C will be opposite by hypotenuse, 24 by 25. And cos C will be 7 by 25. Side adjacent to C. This is the side adjacent to C by hypotenuse. Okay, so we written it. Now, do you see any relation between the sine of A and cos of C? You can see the values are same. So we can see that A and C are complementary angles, and in complementary angle, the sine of one angle is the cos of the other angle. Similarly, you can see cos of angle A is same as sine of angle C. So cos of A is same as sine of C. So children, similarly, you can find the relation, try to find out the relation between the trigonometrical ratios of the remaining angles, okay, of A and C. So find out the 4 remaining ratios of A, 4 remaining ratios of C, and find out what is the relation between them. Now we come to the fourth question. Here we are given 15 cot A is equal to 8, which can be rewritten as cot A is equal to 8 by 15. Now using the same figure here, cot of angle A, the meaning of cot of angle A, you have to remember all the meanings. Cot of A means adjacent side by opposite side. So that is 24 by 7. So it is in this figure, but here we are given cot A is 8 by 15. So it is AB by BC. So from this we can say that AB and BC are some common multiple of 8 and 15. So let AB be 8x and BC be 15x. Then by Pythagoras theorem, by solving it, you can get AC is equal to 17x. Now once again, like the previous problem, if you know all the 3 sides, you can find any ratio. So we have found out sin A 15 by 17 and sec A 17 by 8. So children, in this way try to solve the question number 2, 3, 5 and 10 of the exercise.